thermo. Thermo is heat. Thermodynamics is study of heat. After some time, in a few minutes, I'm going to tell you the word thermodynamics is a misnomer. Okay, misnomer means that name should not have been there. It should have been something else. How I'm going to tell you in the next few minutes. Before I move to the subject, the fundamentals of thermodynamics, I thought most of you, the present generation, they somehow ignore the importance of units. That is one of my observations. I don't want to blame you or anyone, but the teachers, some of the teachers who have been teaching you, they are also relatively younger people, probably in the age group of say 30 to 40. Even they do not give proper importance to units. But in mechanical engineering, particularly in thermal subjects, knowledge of units is extremely important. That is the reason why, even though the time available is limited, see today, Sunday being a Sunday, I am able to spare a couple of hours, but there is no guarantee that I can, how many Sundays I can spare. So ideally, if I am free, I can teach you for 2 hours. It doesn't matter. I'll be happy if all of you listen to me and then follow the subject and get through the exam. That is the basic purpose of this, right? So I'll just spend some time, probably another half an hour or so, on some basic fundamental units or the knowledge of units and dimensions. Laws of nature are described by physics. This involves measurement of and understanding of different physical quantities. SI system is followed throughout this course. SI stands for System International D Units. It's actually a French word. However, the students are expected to be familiar with other systems of units and the conversion from one system to the other. SI is an absolute system of units based on a unit of force independent of the value of acceleration of gravity. So we have 8 fundamental units. We have totally 8 fundamental units. First one is length. As you know, all of you know, length is measured in meters. Length is measured in meters. Mass in kilograms. Time in seconds. Incidentally, time is measured in seconds in all the systems of units. That is probably the only quantity which is measured in seconds in all the varieties of systems of units. Electric current is measured in amperes. You don't require this much, honestly. Temperature is very important because just now I told you thermodynamics is the study of heat in a way, but it is something more which I am going to tell you as we complete this topic in the next few minutes or so. Temperature is measured in Kelvin, and Kelvin 0 degree centigrade is equal to 273.15 degrees Kelvin. When you write Kelvin, don't put a degree symbol. Please try to understand here. If you want to say 23 degrees centigrade, you put 23, 0 you put it as a superscript and then say centigrade. Same thing if you want to put Kelvin, say 300 Kelvin, it is 300 space K, capital K. That's all. No degree symbol for Kelvin. Please remember this. So 0 degree centigrade is equal to 273.15 Kelvin. Since 0.15 is very, very small, it is most of us generally know we ignore the 0.15. So degrees Kelvin is equal to degree centigrade plus 273. Another fundamental unit is to measure the amount of substance. The measurement is done in moles. This also, fortunately or unfortunately, you don't use it much in your thermodynamics course for the time being. Next one is luminous intensity. It is the light. It is the luminous is light. Luminous intensity is the measurement of light. For example, you have bright. Sometimes you see very bright. So you can't see directly the sun because the brightness is very, very high, and it is a little harmful also. But you can see the moon very comfortably, right? So sometimes light is very less, so immediately you switch on the light, or sometimes the light is very high, so you want to put the curtain or something like that. So measurement of light or the luminous intensity is done in candela or candles. Other than this, you have two supplementary units. One is plane angle, which is measured in radians. So angle is always measured in radians. Pi radians are equal to 180 degrees centigrade, 180 degrees. Pi radians are equal to 180 degrees, where pi is your standard pi, that is 22 by 7. Actually, the value of pi itself is a big topic for mathematicians. Value of pi is, you draw a circle, measure the circumference of a circle, and divide the circumference of a circle with the diameter. So we know very well the circumference of a circle is pi d, and diameter is d. So pi d by d will give you pi. Incidentally, this pi value is not an exact value. So 22 by 7 is an approximate value. And now the mathematicians for the past say 200 years or more, maybe several hundred years, they have been trying to find out the exact value of pi, but they are unable to do till date. So pi value for our purpose we take it as 22 by 7 or 3.14156, something like that will come. Another one is supplementary angle or solid angle, which is measured in steradians. This comes in three-dimensional trigonometry, which again you don't require much. So I just summarize, just go back. I want you to be very clear with length is measured in mass, meters, mass is measured in kg, time is measured in seconds, current is measured in amperes, temperature is measured in Kelvin, and angle is measured in radians. Please remember here, angle is, even though we have 50 degrees, 60 degrees, 90 degrees and things like that, the angle is measured and described in radians. And the conversion factor is pi radians are equal to 180 degrees. Now, I want you to know a little bit about the prefixes. With these prefixes will be used to denote very small quantities or very large quantities. Let us start with the small quantities. Milli stands for 10 to the power of minus 3. That is 1,000. 1 by 1,000 is milli. Micro is 10 to the power of minus 6. That is 1 by 1 million. So tomorrow when you go to United States, you don't ask them in lakhs and crores. Lakhs and crores, that kind of words are used only in India. So it's always, if you go abroad, particularly developed countries, they do the measurements in millions and billions. Still, I want you to know, 1 lakh is 10 to the power of 5, 1 million is 10 to the power of 6, 1 crore is 10 to the power of 7. And you don't know anything, try to just listen to me and follow this PPT. This will be shared by Ramesh sir to you. There is absolutely no problem. You can take it and use it. So concentrate on listening. And if you have any doubt, please raise your hand. Since we are a small group, we can always discuss across. Now I have a small question to all of you. What is a micron? Anybody? Just answer. I just join in a few seconds.
Anurag, who are all there in the class? May I know the names? Who are all there in the class? May I know the names? Names,
sir. I'm not aware of the names, sir. I mean, seeing their roll numbers, I cannot see the names. Please ask them to respond on themselves.
Yeah, can somebody answer the question? What is the micron? Micron, M-I-C-R-O-N. The answer, near answer is given in the PPT itself. Anybody? Micron is
-6.
Yes.
10 to the power of -6.
minus 6 is micro. I am asking you clearly, the question is slightly different. What I want is, what is a micron? M-I-C-R-O-N. Micro is given. What is micron? Yes.
1 micron is 10 to the power of minus 6 meters.
That's it. So what does it mean? Can anybody tell the difference between micro and micron? The answer given is correct.
Sir, which cannot be sensed by our human body, some human.
Yeah, human eye cannot, it is impossible to detect. So I am not looking at that answer. I am looking at a different answer. Okay, fine. Since still we haven't reached the common platform, micron is a measurement of length. That's what I want you to know. Micron is a measure or unit of measurement of length, which is used for certain purposes when you are looking at small quantity. 1 micron equal to 10 to the power of minus 6 meters, which is also equal to 1,000th of a millimeter. 1,000th of a millimeter. Now everyone is talking about nanotechnology. Nano is 10 to the power of minus 9. And pico, femto, atto, again, you don't need to learn much. But coming to the higher quantities, kilo is 1,000. See, 1 meter and 1 kilometer. 1 kilometer is 1,000 meters. Similarly, 1 gram, 1 kilogram. 1 kilogram is 1,000 grams. Mega is not megastar Chiranjeevi, but mega is 10 to the power of 6. See, please remember this micro and mega are two sides. Micro is 10 to the power of minus 6, 1 by 1 million. Mega is 1 into 10 to the power of 6, that is 1 million units. Normally in power it is used megawatts, kilowatt, megawatt. Kilowatt is 1000 watts and megawatt is 10 to the power of 6 watts or 1 million watts. Giga is 10 to the power of 9. Okay, this much if you understand, it is fine. Now, yeah, I think whatever question I asked you a few minutes ago, same question I have put it. Just observe this slide. I am going to explain to you one by one. 1 micron is 10 to the power of minus 6 meters or 10 to the power of minus 3 millimeters. It is a unit of length. Another one is 1 angstrom, which is also is 10 to the power of minus 10 meters, which is a very, very small thing. It is also unit of length. Can anybody answer where angstrom is used?
Angstrom.
You have used it, I am sure. Think over, you can answer. When you are measuring the wavelength of light, right? Wavelength of light optics, there is a spectrum, and the spectrum has the 4,000 angstrom units, something like that. Okay. Now, 1 nanometer is 10 to the power of minus 9 meters. Nanotechnology deals with less than 100 nanometers. Less than 100 nanometers. That is 100 into 10 to the power of minus 9 gives you 10 to the power of minus 7. As I told you, 1 crore is 10 to the power of 7. So 1 by 1 crore is typically that is the level of size. Nanometer is 1 by 1 crore. 1 by 1 billion. 1 billion is 1,000 million. Normally in the newspaper you might have seen the foreign exchange reserves are so many $1 billion. Now I will give you another small question which I am sure most of you will answer. Can you convert $1 billion into Indian currency? You take $1 as 75 rupees. To solve this problem, you can use pen and paper, but without pen and paper, most of you can answer. Please convert 1 billion American dollars into rupees, equivalent rupees. Do that, everyone please. 1 billion American dollars and what is equal to so many Indian rupees?
$1 billion.
$1 billion. See, you have all the things. I already told you what is 1 billion. Dollar also I told you $1 equal to 75 rupees. I just close the door.
700 crores. 700 crores. 1 million.
Said $1 is how many rupees?
25 rupees.
25 rupees, sir.
Then do it properly.
This is 75 rupees into 10 crores. 1 billion is 10 crores.
1 billion is?
10 crores.
That's why. So
Billion.
my question is valid. You have not understood. Think over correctly. Billion is not 10 crores.
100 crores.
Billion is 100 crores. Do it now.
Sir gave the clue. Do it.
Ramesh,
Sir.
this units is a highly neglected subject in engineering.
Sir,
Maybe
75 into 10 to the power of 9, sir.
75 into 10 to the power of 9. Okay, correct answer. But I am comfortable in crores. Can you convert in crores and tell me? Because I am an Indian.
Okay,
$1
sir.
billion. Yeah. How many crores of rupees?
7,500 crores, sir.
7,500 crores is the correct answer. So whenever tomorrow if you come across $1 billion, simply you understand that it is 7,500 crores because of the dollar conversion. Now a much simpler question I will ask you. What is 1 million American dollars? You should tell fast. 1 million.
American dollars. 7.5 crores.
7.5 crores. Wonderful. So 1 million American dollars is 7.5 crores. 1 billion American dollars is 7,500 crores. Right? Right. Now let us do little more conversion and quickly move to the subject. 1 inch. Now just now when I ask a question, sir, just now you told that we are going to use SI system of units. Why you are going for inches? Tomorrow, unfortunately or fortunately, if you go to United States and the UK, they are still using some of these units. So suddenly you should see in America, they are still using pounds. For example, you want to buy some chicken in a warehouse. So the quantity that fellow is giving is 5 pounds, 10 pounds, like that. He will give a large turkey or chicken or something like that. Okay, so you need to be familiar with some of the units, if not for the exam, but otherwise. 1 inch is equal to 2.54 centimeters exactly. And if you take a small ruler, steel rule, generally most of you will be having, it is 12 inches on one side and it is 30 centimeters on the other side. Now 1 foot is equal to, representation also I want you to follow it, 1 inch, 1 double quotes. 1 double quotes or 1 double prime, what you have to say. 1 foot is 1 single prime, it is equal to 30.48 centimeters exactly. 1 yard is equal to 3 feet, which is, yes. Yeah, please unmute and then question. Please.
Sir, your voice is not clarity, sir. Getting some noise, sir.
Nice, is it? I think AC may be the problem. Okay, sure.
Now it's okay, sir.
I think AC is the problem. Okay, I switched off the AC. Good.
Arvind made non-AC for sir today.
Okay. It's good in Vijayawada,
No,
no
sir,
problem.
sorry, sir.
Vijayawada is highly humid. High humidity. Psychrometry we have to learn.
The climate is slightly not so bad. Okay. Yeah. Now everything is clear. Picture as well as audio.
Yes, sir.
Are you,
Yes, sir.
are you enjoying the subject?
Yes, sir.
Sir,
Yes,
very
sir.
much.
I want you to learn the subject by enjoying. Don't think that why sir is not started thermodynamics. It will be started very soon. Okay. Just another 15 minutes. We'll move to the subject. Now another thing is, some of you may be having some lands somewhere. So they'll be dealing with the acres. So please don't think that these are not SI units, so I'm not going to use. SI units we use mostly, but then I want you to be familiar with some of the very important ones. I chose only such kind of things in this PPT. 1 acre is 4,046.86 square meters. What is 1 square meter? Can anybody explain briefly? 1 square meter? What exactly?
1 meter box, sir. I mean 1 meter square of the area.
little better? Yeah, I know that you know it, but then can you explain a little better? See, it's a plain area of 1 meter length and 1 meter breadth. Okay, that is 1 meter square, which is equal to 4,840 square yards. Similarly, the message has come that meeting will end in 10 minutes. Don't worry if the meeting ends. Immediately I will start one more meeting after with giving 5 minutes break. So you can always log in. No, we'll continue. We are going to continue at least one more class. Right. 1 hectare is another word which is used particularly by the government when they explain so many hectares of area. So 1 hectare is 10,000 square meters. That means the area is, if you consider a square, one side of the square is 100 meters, another side is also 100 meters. That is equal to 10,000 square meters, which is equal to 0.01 square kilometer. So if you go ulta, 100 hectares are equal to 1 square kilometers. Okay. Now 1 pound is 453.6 gram. So again, you know, I refer to USA. Go to America and ask for instance, chicken. You can't ask 5 kg chicken, that fellow will not understand. You have to ask maybe, you know, several pounds of chicken, maybe 10 pounds or something like that. And again, you know, in news you will be seeing crude oil prices are falling, increasing and all. So 1 barrel of crude oil is 42 US gallons, which is equal to 159 liters. So I just close with one more American word. They don't use petrol. In America, almost in developed countries, all passenger vehicles run with petrol. All cargo vehicles like your trucks and buses run with diesel. Whereas in India, we have passenger vehicles in both petrol and diesel. Okay, that is one of the things. Second thing is, they don't call petrol as petrol, they call it as gasoline. And that gasoline, they will cut short and call it as gas. So in other words, if you go to America, you will hear as gas. Gas means it is exactly equal to the petrol which we are using in India. Now, before we move to the thermodynamics, we go to physics. As I told you, another 5 minutes, the link will be cut. Just don't worry, relax for a couple of minutes. And by that time, I will create one more link and send it to you. So the entire engineering, in my opinion, for that matter, the whole gamut of science and engineering and technology derived from what is known as general science. At that time, this many subjects were not there. In the general science, for mechanical engineers, the most important topic is physics. So unless you have some little fundamental grip over the fundamentals of physics, you cannot move forward, particularly in mechanics, which again leads to thermodynamics. That's why I have given the title for this slide as physics, mechanics and thermodynamics. So we start with a simple definition of velocity, which you might have studied in 8th or 9th standard in physics, or maybe 10th standard. Velocity is defined as rate of change of displacement. In SI units, velocity is measured in meters per second. This is very important, and we are going to live with this velocity for the rest of our lives being mechanical engineers. From now onwards, whatever I am going to explain to you are very useful not only for this thermodynamics subject, but for whole of your life, in case you don't convert yourself into a software engineer. Acceleration is defined as a rate of change of velocity and is measured in meters per second square. Velocity is a vector, acceleration is also a vector. And all of you are aware of vectors have both magnitude and direction. Scalar has only magnitude and no direction. Point of time, I will also refer to what is known as acceleration due to gravity. In other words, if you throw one stone somewhere to up, depending on your strength, it will reach maybe 5 meters, 10 meters, 20 meters, but then it will stop somewhere and then fall. That is due to gravity. So on Earth, the gravity value is 9.81 meters per second square. That's why, if we, for example, if an aeroplane is traveling somewhere and some failure with the engine, which means it cannot move anywhere. So obviously it is going to fall. And please remember, this acceleration due to gravity is not an exact value. It changes from one place to other, but not so much by a very, very marginal way. At the polar region, it is slightly more. At the equator, it is slightly less. But on in overall in the on Earth, if you want to use this acceleration due to gravity, you can take the value as 9.81 meters per second square. Now coming to velocity and acceleration, now we really go to the physics or mechanics. The most important law of mechanics is Newton's second law of motion, which defines force. So it says 1 Newton is the force that is required to bring 1 unit of acceleration in a unit mass. So if you with the consistent unit, since it is not a very big thing, so you can always understand that work is equal to force is equal to mass into acceleration. Mass into acceleration is measured in newtons. Here I want to tell you one very important rule. If you want to, please remember, this is a very important rule. When you, I have seen, being a teacher in for the past several years, when I give a problem, they solve the problem, finally they get an answer, 2350, let us say. 2350 what? There has to be some unit. Generally, students are little careless, that's what I observe. And some of them don't know, but majority of you don't know it, but then you don't put the units. So when you are putting the units, assume you want to say 2350 newtons, right? So there are two ways of representing it. Please understand, try to understand, this is a very important point. A lot of people don't bother, but then I'm very particular that I want all my students to
you